We've all seen that image, right? The giant, terrifying mushroom cloud. It's an icon of destruction. But what actually happens underneath it? What are the ripple effects that spread out second by second from a single nuclear blast? Well, today we're going to look right past that flash of light and dive into the devastating reality that follows, from the first microsecond to the decades that come after.
Okay, so let's picture a major city. For this, we'll use a scenario that focuses on the Pentagon. The second a pretty standard 300 kiloton warhead goes off, it doesn't just explode. It creates this superheated ball of plasma, basically a man-made star, that inflates to a mile wide in just a few seconds.
Now, the temperature inside that fireball, it's almost impossible to wrap your head around it. We're talking 200 million degrees. To put that in perspective, that is way, way hotter than the core of our sun. At that temperature, things like concrete, steel, the earth itself, and, of course, people, they don't just burn, they are instantly vaporized. They just cease to exist. Right behind that blinding light and heat comes the blast wave. And this is a wall of pure compressed air moving at 750 miles per hour, faster than the speed of sound. Now, this isn't wind. Oh no, it's a crushing physical force that can flatten reinforced concrete buildings miles away from the center and toss cars around like they're toys. And if you survive all that, well, after the blast wave rips through, the intense heat ignites everything that can possibly burn. Broken gas lines, ruptured fuel tanks, they all feed these new fires, creating what's called a firestorm. And this isn't a normal fire. It's so intense, it creates its own hurricane-force winds, with temperatures soaring above boiling, completely incinerating an area up to 65 square miles. So, that horrifying sequence of events we just walked through, that's the scenario for just one single, relatively common nuclear warhead. But that's just one bomb. And the truly terrifying reality is that the world's arsenals hold thousands upon thousands of them. You know, as of today, 9 countries have these weapons. Russia and the United States, as you can see, hold the vast majority of them. We're talking thousands each. But even the so-called smaller arsenals held by countries like China, France, or Pakistan have more than enough power to completely change the course of human history. This isn't some theoretical threat from a movie. It's a very real part of our world. Now, here's where it gets really interesting. One of the absolute most devastating effects of a nuclear weapon isn't the blast at all. In fact, it's completely invisible, and it could happen hundreds of miles above the Earth, crippling an entire continent in the blink of an eye. It's called a high-altitude electromagnetic pulse, or HEMP for short. If you detonate a single nuke, say 20 or 30 miles up in the atmosphere, you don't get a fireball or a shockwave on the ground. No. Instead, it unleashes this massive wave of electromagnetic energy that could, quite literally, send modern society back to the 19th century. A HEMP attack actually hits in 3 separate waves, and it all happens in under a minute. First, you get the E1 pulse. It's this instantaneous burst that fries tiny microelectronics. Your phone, your computer, your car's ignition system, gone. Next is the E2 pulse, which is kind of like a widespread lightning strike that takes out bigger, less protected systems. And finally, the E3 pulse. This one is slower, but it's a brute. It sends powerful currents surging through long power lines, overloading transformers, and physically melting them down, essentially destroying the electrical grid for years. Okay, so let's get back down to the ground. After the initial blast and the electronic chaos from above, a much more sneaky, insidious threat begins to drift down from the sky. We're talking about nuclear fallout. This is all the radioactive dust and ash that gets sucked up into that mushroom cloud, gets irradiated, and then gets scattered by the wind for hundreds of miles. And unlike the blast, this is a silent killer. It poisons the land, the water, and anyone who's exposed to it, not just for days, but for years or even decades. And this isn't just a model, it's horribly real. In Hiroshima, this fallout actually mixed with the moisture in the air and fell back down as this thick, greasy, radioactive black rain. Survivors, desperate for water, drank it, and they were soon overcome with acute radiation sickness. This is the recorded, horrific experience of real people. So far, we've really only been talking about what one bomb, or maybe a limited attack, could do. But what happens if a regional or even a global nuclear war breaks out? Well, the consequences scale up to a level that's hard to fathom. We're no longer talking about destroying cities. We're talking about changing the climate of the entire planet. And this brings us to the concept of nuclear winter. Imagine those massive firestorms we talked about, but happening in dozens or hundreds of cities at once. They would pump millions of tons of black soot high up into the stratosphere, and that dense layer of smoke would then spread around the globe, basically acting like a shroud, blocking the sun's light and warmth from reaching the Earth for years. Climate models on this are just terrifying. They predict a catastrophic drop in temperature. And we're not talking about a chilly winter. Large parts of North America and Eurasia, the world's bread baskets, could see their average temperatures plummet by over 20 degrees Celsius. That's about a 36-degree Fahrenheit drop. It would be a climate catastrophe totally unprecedented in all of human history. So here's the crucial point to understand. During the actual Ice Age, global average temperatures dropped by about 5 degrees Celsius, and it happened over thousands of years. Nuclear winter could cause a cooling that is 4 times more severe, and it would happen in a matter of months. Humanity has never, ever experienced anything even remotely like it. The consequences of that are a total system collapse. Global food production would plummet by over 90%, leading to mass starvation on a scale we can't imagine. That soot in the atmosphere would also shred the ozone layer, meaning any little bit of sunlight that did get through would be packed with dangerous UV radiation. Growing seasons would basically disappear for years, triggering a global famine that could kill billions of people. So, after all of this, the blasts, the radiation, the freezing darkness, the big question is, could anyone anywhere actually survive and rebuild? Well, some research points to a few very isolated places that might have a fighting chance. Some studies suggest that a few remote island nations, mostly in the southern hemisphere, could be the most resilient. Places like Australia, New Zealand, and maybe Iceland could potentially produce enough of their own food to feed their people, since they'd be shielded from the absolute worst of the cold and fallout from the north. But, and this is a huge but, there's a massive catch. Even if they can grow food, these nations are completely woven into the global system. Without international trade, how do you get fuel for your tractors? How do you manufacture life-saving medicines or spare parts for, well, anything? The complete and total collapse of globalization would threaten even these last potential safe havens with a societal breakdown of their own. And that leaves us with the final, pretty sobering question. Surviving the initial blast is really just step one. The real grinding challenge would be enduring the broken world that comes after. It forces you to ask, in a world plunged back into darkness, without technology or trade, what is truly left to survive for? And it really underscores why we have to make sure these weapons are never, ever used.